Okay, so we're talking about sine, cosine, and tangent. There was a famous saying. Remember it? SOHCAHTOA. We're reviewing geometry, and probably the number one thing you needed to come out of geometry with was a good sense of different shapes. And the number one shape you needed to be really good at was triangles. Because triangles come up in geometry, in trigonometry all the time. And trigonometry is going to be the hardest thing you learn next year. Okay, whether you're in honors pre-calc or regular pre-calc, it's the hardest thing you will learn is the trig. And it doesn't, if it was just sine, cosine, and tangent, it'd be easy, but it gets much more complicated than that. So this is the basic of all of it, though. So would you please write down SOHCAHTOA and then try to use that to answer these three questions. What is sine? Don't say it, write it on your paper. You can abbreviate it if you want to, as like O and an H, but you need to know what to do with them. Sure. SOHCAHTOA. Can you get into the notes? There are notes for this, you guys. They are posted. And it's still fractions that you're making. So if you were going to just label this as two letters, you've got them perfect. Would you just read them to me? What would it be? O over H. How about cosine? A over H and O over A. And those come up so often. I mean, seriously, even though I've been teaching this now for a long time, and when I get into a complicated trig problem, I'll often end up saying, instead of saying tangent, what do you think I'll say? TOA. Because it reminds me it's opposite over adjacent. Okay, so these are good to know. So if I pick this angle right here, we oftentimes use that goofy looking letter right there. That's called, do you know what? A theta. It's a Greek letter. And if I take it from that angle's perspective, this one's adjacent to it and that one's opposite. But if I was coming from this perspective, then this one would be the adjacent one here. And this one would be the opposite one over here. So it all depends on which perspective you're going to take. But if we label that as being our theta, then this one is the adjacent. Adjacent means right next door. And this one is the opposite over here, which is across from it. All right. Now, let's just take a second here and remind you of the two major triangles that you were supposed to know from geometry. 45, 45, 90, very good. And what? 30, 60, 90. Would you please sketch those quick and put the numbers on the sides of them? Some of you will remember those numbers, those ratios, and some of you won't. Those of you that don't have them fresh in your mind, you need to get them back into your head, because these come up also all the time. In trig, you're constantly using 30, 60, 90s and 45, 45, 90s. All right, and I hope it's kind of intuitive to you that these two sides are equal to each other, the same size. 1, 1, and then what's the other one across from it? Square root of 2. How many of you knew that one? Not too many. Okay, you need to know that one. Write it down. It'll help you remember it. 1, 1, square root of 2. And then the other ones, this is the smallest side, so that's a 1. What do I do from there? Remember? Remember? 2. And which one is it? Is it the hypotenuse or is it the other one? The hypotenuse is the 2. It's because the longest side and the shortest side have the best chance of being that ratio of 2 to 1. Anyway, and then this one over here, square root of 3. And it's easy to forget that because this one's on the hypotenuse and it's a square root. So people think the square root goes here sometimes. It doesn't. All right. Those are really crucial. All right, let's go back to this kind of a problem. Let's say I was going to find that y. Do I do sine, cosine, or tangent? Well, I look at this and say, okay, if I'm using this 50s perspective, what do I have? What's this called? What is this called? Adjacent. What's this called? Opposite. So which one has opposite and adjacent in it? Tangent. That's why we pick tangent of 50 is equal to the opposite side, y, over the adjacent side. 8. Tangent of 50 equals y over 8. Now, with a calculator, you can type in tangent of 50. We don't expect you to know tangent of 50 off the top of your head. So grab a graphing calculator. Doesn't even have to be graphing as long as it's got sine, cosine, and tangent on it. You could even use the app on your calculator for this one. It would work fine because you just got to type tan 50 equals. The only thing that's tricky is you better make sure it's in degrees. So if you happen to by accident use radians for it, 50 radians is all totally different than 50 degrees. Totally weird answer comparison. Yeah, it is. The person who made the smartboard decided to go with a candy theme for that day. I don't know. There's a lot of sugar in the math department right now because it's Sam's last day, or Mrs. Redepenning's last day. So I brought in treats. So, all right. Did you figure out what tangent of 50 was? Somebody must have typed it in. What was it? In the front row. 1.19? So see how I can just put that right there? And now if I want to get the y alone, what do I have to do to finish? Times by 8, because it's being divided by 8. So I times by 8 here, and I times by 8 here. And 8 times that must be like 9, 10 point something? 9.53. And that must be what y is. Then you just need to do the smell test. Does that seem reasonable to you? That side being like 9.5, does that seem reasonable to you? Yeah, that seems reasonable to me. If they had said that side was supposed to be like 70 or 95 because you had the decimal in the wrong spot or something, you should be realizing, wait a minute, that doesn't make sense. I mean, because this angle's 40 and this angle's 50, so I get that this side should be a little shorter than this side. So that makes sense. All right. There is no triangle in the Milky Way bar. Like this? You're really stretching for that one, but okay. All right, this one. Without me. Try to figure it out. Oh my gosh. It's not a triangle. Yeah. You want to be in degrees, yes. You don't want your calculator in radians. All right, so the first thing you ask yourself is was I given opposite, or was I given adjacent, or was I given hypotenuse? What was I given here? Would you agree that that is the adjacent side? Yep. So I have to use something with adjacent. Well, there's opposite over adjacent, or there's adjacent over hypotenuse. Which one should I use? Ka, which is also known as cosine. So cosine of 31 is, and I sometimes put these little helper things next to it. Cosine is ka. And then adjacent over hypotenuse. Adjacent is 13. Hold on. Over hypotenuse is x. There we go. Now I just need to know what a cosine of 31 is. I have no idea. Use your calculator. 0.85 something? And then I'm going to multiply both sides by x and then divide both sides by 0.857 to get that all alone. It'll be final answer 13 divided by 0.857. Thank you. And again, do the smell test and say, does that seem reasonable? You just don't want to, whatever, 0.1716, all depends on the rounding. So let me think. It's just slightly bigger than that side. Does that make sense to me? Yeah, it makes sense to me. This is almost a 30-60-90 triangle. If it had been a 30-60-90, this would be the smallest side. This would be double that. It would be like 7. I can buy that. Okay. There's your basics. You remember this one? 1 square root of 2? Remember this one? The 6, and 6 times the square root of 6, of course. What I'm trying to say here is, if this and this are 45 and 45, then that means, oh, it's one of that kind. Does that mean the sides are automatically 1 and 1? No. But that means that this and this are always equal. So this is 6 then, right? And then the other one is always going to have a square root of 2 in it. And so I could say 6 times the square root of 2. 6, 6, and 6 root 2. Do you get that? Let's look at another one like that. This time, this is the tougher kind. Normally there's a square root of 2 right here, but there's a 12 there. So, think of it this way. This side right here would have to have a 12 in it because you're going to use the 12 to get it. You want to take a guess on what you do to get the answer for that side? 12 divided by the square root of 2. Very good. And if you know that side's 12 over root 2, this side must be 12 over root 2. And some kids ask me, why? Why is that? Isn't there, there's no square root there. Well, if you really wanted a square root there, you could multiply this by the square root of 2. And then I'd have to multiply this by the square root of 2. And I have to multiply this by the square root of 2. And then I'll have a square root there. And watch what will happen. This will cancel that. This will cancel that. And then it'll be 12, 12, and 12 root 2. I don't know if that works for you or helps you understand it, but what I do whenever I get the side that was supposed to have a square root, I just say, oh, well then, the other side has to be that number divided by the square root it would have had there. All right, so let's see if you can transfer that. Here's a 30, 60, 90 triangle, except it's a 60, 60, 60 triangle to start with. But when you divide it down the middle, do you get that that turns it into a 60 on the one corner and a 30 on this corner? Does that make sense to you? All right. And so then if this side is 2, then this side would have to be half of that, which would make it a 1, right? 1, 2, and then how would I get this side right here? I know it's the square root of 3 because I've memorized that thing. But do you know how you'd find it? It's just the square root of 3. But what I'm trying to say is, how do I get that? How could I prove that? Do you know some kind of a formula that would tell you that? Pythagorean, that's right. So a squared plus b squared has to equal c squared, and these are a and b. So let's just call this b for a second. 1 squared plus b squared would have to equal 2 squared. So 1 plus b squared would have to equal 4. So now I subtract 1 from both sides. B squared has to equal 3. So b must be the square root of 3. There you go. I just did a squared, b squared, c squared. You guys know how to do that. And I just stuck in 1 and b as my two sides. 1 and b. All right. I was just trying to show you how you get that 1, 2 square root of 3 triangle to come up. All right, so let's say you had this one on the SAT test. This is a very typical basic trig question on the SAT test. All right, what is x and what is y? Well, since this is a 30, 60, 90, do you agree that this is supposed to be the smallest side? And this is supposed to be the biggest side, and do you remember how much bigger it is? Twice as big, so what's that x got to be? 4. And then how do I figure out the other side? It's got to have a square root in it, right? Well, think about this. This is 4 times bigger than the original one we start with, which is the 1 and the 2, you know? And these numbers are 4 times bigger than that, right? So what's this one got to be? 4 square root of 3's. Because we could say this 8 is like a 4 times 2. And then do you see this is 4 is like a 4 times 1? And then I've got my original numbers in there of 1, 2, and the square root of 3. And they're all just 4 times bigger than they used to be. All right. If that doesn't work for you, you can at least know that, okay, this one's supposed to be twice as big as this one, so this is supposed to be a 4. Do you get how that's a 4? All right, and the other side here is just always whatever this number is times the square root of 3. 4 root 3. All right. I think that's enough trig for now. You got the rest of the hour, which is like 15, 17 minutes. You can work on your homework, which is more trig problems just like this. If you need help, I will gladly help you.